A stationary body of mass m exports into 4 identical fragments in free space. 3 of them fly mutually perpendicular to each other with the same kinetic energy k. Stationary body of mass m now let this be the y-axis, x-axis, z-axis. So here is a, I'll keep a body of mass m. It is at rest, no? It will explode now. 3 of them fly mutually perpendicular to each other with the same kinetic energy. 3 of them, they'll fly. No. This is y-axis, x-axis. 3 of them. So it will explode into 4 identical fragments. So shall I put m by 4 here? One fragment, another m by 4, another m by 4. And they must have, since kinetic energy is same, so they must have same speed, or vz, vx, vy, and vx equal to vy equal to vz equal to v. Speed of center of mass of system of explosion. So it's like a Deepavali cracker. So what all that explosion occurs, internal forces will act. What is that explosion usually? What happens? So it's like a chemical, no? There'll be chemical, and we are going to lit it. We are going to ignite the reaction. And during chemical reaction, what all forces that act, they are molecular forces, and they will become internal to system. And we know center of mass will not accelerate due to internal forces. And what is the state of center of mass at rest? So therefore, still center of mass of the system will be there only, though the fragments are moving. Where the center of mass will be there only. Because it was at, it will retain inertia of rest, center of mass at rest. So the center of mass will retain inertia of motion. And internal forces due to explosion, internal forces act, internal forces only act on the system. So therefore, internal forces cannot accelerate center of mass. Already this we have concluded. One more fragment we have to trace it out. So definitely the one more fragment here, I think the rough diagram. I don't know the velocity of the fourth fragment. I'll write V4. So it should be somewhere in some, it should move in a space. Is it okay? No? So there's a condition. So this idea, internal forces cannot accelerate. So center of mass will retain its inertia of rest position. So therefore, what should be the velocity of center of mass? Speed of center of mass system after explosion should be 0. Speed of the fourth fragment is, okay, let's do one thing. What is the with the same kinetic energy telling? So shall we write kinetic energy with the same kinetic energy? So what is K is equal to here? K should be equal to mvx square by 2 or mv square by 2. Shall we apply conservation of linear momentum? This is the initial. This is the final. Shall we apply? So applying conservation of linear momentum, initial momentum. Don't write pix. Momentum you have to convert in space. So initial momentum 0, final momentum m by 4 bi cap. I'll write it directly, m by 4 v j cap, m by 4 v k cap plus m by 4 v4 bar. So solving this, we will get expression for the v4 bar. So what is v4 bar is equal to? V4 bar should be equal to, this will be minus of vi cap plus j cap plus k cap. What is kinetic energy? How related to this one? V is equal to 2k by m. The speed of that should be equal to 2k by m. Speed is asking. Okay, later on I'll check it now. So this should be the 2k by m I cap plus j cap plus k cap. This is the speed of the fourth mass. There's the velocity. So what is the speed? 2k by m. This should be equal to root 3. It will come. So this will be 6k by m. Okay, no? So like this, the speed of the fourth fragment from conservation of momentum, I'll get expression for V4 bar. Then I'll proceed like this.
No, then it is option A.
Okay, what we got it? Okay, some maybe. Option A is there, huh? 6k by m. Yeah. I'm unable to. Let me. 6k by m. We are getting check calculation once, huh? Check calculation once. Mass is m by 4, no? Okay, that one. Actually, speed of the fourth fragment, no? So what is the kinetic energy of the speed of the fourth fragment is asking? Only speed is asking, no? Okay. Here some correction I have to do it. M by 4. M by 8. Eight k by m. Okay, some correction is there. 8k by m. So this will be so this will be 24 k. I think now okay, fine. 4 sigma. So yeah, what he has given is correct. Huh? Check once. Huh? There should be the speed of that one. Here mass m by 4 is what we have to take it. Huh? I'm like mass of each fragment is m by 4. Total energy relieved in explosion. How to calculate that? So that total energy released should be equal to m by 4, and I'll magnify it. Okay, we'll write it. Total energy released in the explosion will be half into, I think there are 3 fragments, they have same speed, no? So directly, let me go for it. 3 times of half into m by 4 v square plus half into m by 4 v4 square. So substituting this and express in terms of k. You'll get 6k, that one. Check it. So this is the energy release. From where this energy has come? From where this energy has come? The chemical reaction. Suddenly chemical reaction suddenly occurs, and due to chemical reaction energy release, that energy will be converted into the kinetic energy of fragments. What is the phenomena of the crackers or the bomb? That one. A sudden explosion. What does it mean? A sudden chemical reaction occurs. Huge amount of reaction takes place. So huge amount of energy release. Sudden release of that energy. So the chemical energy itself, what happens, will convert it into kinetic energy of fragment. This is the basic idea of explosion. What is the explosion? What occurs? The reaction will not occur gradually. Suddenly the huge amount of reactions will take place. Almost all the content will, almost all the solution, or you can say the reactants will undergo reaction simultaneously. Will get huge amount of energy, and what all that force acting are internal. So what will happen to that energy release suddenly? Will get converted into kinetic energy of center of mass, or kinetic energy of the fragments, and center of mass will be at rest. This is the one basic idea. Means now next question comes like, so like if a moving fragment, if it expands, then how you manage? Let me cover here only. If a moving fragment, means a fragment is moving and explosion occurs. A fragment of say 4m, it is moving with a velocity v0. It's having some initial kinetic energy. Explosion occurs. And due to explosion, one will have mass m, other will have 3m. Let the velocity be v1 and v2. And due to explosion, some energy will be released. Okay, clear now? So due to explosion, some energy will be released here. What is E0? E0 energy released. During explosion. And tell me what will happen to this energy released? Already it's having kinetic energy, no? Due to explosion, energy released. So we have to conserve not mechanical energy, the total energy should be conserved. The total energy should be conserved. So applying conservation of momentum. And net force on the system along x-axis 0. So initial momentum equal to final momentum. Initial momentum 4m v0. Final momentum mv1 plus 3mv2. Then what about the total energy should be conserved? So initial kinetic energy 4m by 2 v0 square. This energy released should be taken in LHS. Should be equal to finally. Now there are two things are there. Energy released during explosion. If 1/4 of energy is utilized to impart kinetic energy, remaining 3/4 convert into sound. In that case, what you are going to write? 1/4 you are going to write it. Half of the energy released is converted into sound. Remaining half is utilized to impart kinetic energy. So it can happen, no? So this E0 what happen? If the total energy release converted into the kinetic energy of fragments, these are fragments, kinetic energy of fragments. So then in that case, you should write equation like this. 1/4 of energy convert into sound. Then how much will be left over? 3/4. So 3 E0 by 4 you have to substitute. It can be that one. There's no rule that total energy should be converted into kinetic energy of fragments. Fragments, and this is explosive. I think Deepavali, all this happens, no? You might have not noticed. Tell me in Deepavali, what is requirement? What type of explosion we needed? Kinetic energy of fragments or sound? Okay, some, what will happen? Like a crackers, what happen? They should produce more sound. So the kinetic energy of fragments should be made less. And some fragments, what will happen? Kinetic energy should be less, sound should be less, but more like a sparkling should be there. Sparkling means they should be converted into light energy. So like that, what will happen? The crackers I'm going to design. Is it okay? 1/4 converted into light energy, sparkling. 1/4 sound. The remaining what happened, half will be converted into kinetic energy of fragments. So this E naught need not be always. So I'll put it like this. Energy during explosion. 1/4 of energy released in explosion is converted into kinetic energy of fragments. So if I put this condition, then you should write E naught by 4. Total energy converted into kinetic energy of fragments, you have to write E naught. And this, are you very generalized, huh? Just generalized idea, nothing to do with any concept linking here. One more, something related to this.